You know when you get a health insurance quote and you have absolutely no idea how they came up with that number? It can feel like they just pull it out of thin air, right? Well, today we're going to pull back the curtain. We're going to become data detectives and solve that exact mystery using a little bit of machine learning.
So yeah, that's the big question for today. How exactly does an algorithm look at your personal information and spit out a price tag for your health? We're not just going to talk about it. We're actually going to build a system right here from scratch just to see how it's done. Okay, so let's set the scene. Our investigation starts with a really common problem that every single insurance company faces. They've got to figure out, somehow, how much a new customer is going to cost them in medical bills over the next year. I mean, how on earth could they possibly know that?
Well, it turns out they've got this secret weapon, a case file, if you will. It's basically a big spreadsheet with info on more than 1,300 previous customers. And inside, we have all these clues: age, BMI, if they're a smoker or not, and this is the crucial part, the actual medical bills they racked up. This old data, it's the key to everything.
So, our mission, should we choose to accept it, is pretty straightforward. We're going to use this case file to build our own prediction tool, a system that can look at a brand new customer's details and give us a solid estimate of what their future medical costs are going to be.
All right, time to get our hands dirty. Let's put on our detective hats. All the clues we need are right here in this data, but they're not just going to jump out at us. We have to be smart. We need to actually visualize the evidence to spot the patterns that are hiding in plain sight.
Okay, our first piece of evidence seems pretty obvious, right? We make a simple chart plotting everyone's age against their medical costs. And yeah, you can see a general trend. As people get older, their costs tend to go up. Makes total sense. But look how messy it is. The points are all over the place. It's not a nice, clean relationship at all.
And this is where the real sleuthing begins. What if there's something else going on? A hidden clue, some other piece of evidence that could explain why this chart looks like such a big, scattered mess. Let's try adding one more piece of the puzzle to our chart and just see what happens.
And whoa, there it is. This is our big aha moment. The second we color these dots based on whether someone smokes or not, the whole picture just snaps into focus. It's crystal clear. All of a sudden, you can see three totally separate groups of people. The non-smokers are all down here in this neat little line, but the smokers, they're way up here in two different, way more expensive clusters. It's amazing what one little piece of information can do.
Now, what's really interesting is that you might think, oh, there must be a ton of smokers in this data. But nope, they're actually a minority. Only about 20% of the people in our case file are smokers. But even though there aren't that many of them, they are having this massive impact on the costs. That is a giant clue right there.
You know, we can actually put a number on how strong these clues are. It's a thing called correlation. Just think of it like a score from 0 to 1 that tells you how tightly two things are connected. And would you look at that? Being a smoker has a huge score, a 0.79. It's super strongly linked to higher costs. Age and BMI, yeah, they're related, but their link is way, way weaker. I think we've just found our prime suspect.
Okay, so let's recap. We've gathered our evidence, we've spotted some really important patterns, and we've definitely found our strongest clue. Now, it's time to build the machine. It's time to turn all these clues into an actual prediction tool.
And the machine we're going to build is called a linear regression model. I know it sounds super technical and scary, but trust me, it's not. All it really does is find the single best fit straight line that cuts through all those dots on our chart. That's it. It's just a way of turning that chaotic mess of data into a simple formula we can actually use.
And hey, don't just take my word for it. There's this great quote from a data scientist that says a lot of what we call machine learning is, well, it's basically just glorified line fitting. We're telling a computer to do something our brains do automatically. Look for a trend, draw a line through it, and use that line to predict what comes next.
So how does this machine learn? It's actually a pretty simple process, just 4 steps. First, we choose our model, linear regression. Second, we feed it our whole case file, all that customer data. Third, and this is the magic part, the model figures out how important each clue is. It assigns a weight to everything. It learns exactly how much to bump up the price for each year of age or each point of BMI, and most importantly, what to do if someone's a smoker. And once that's done, the machine is trained and ready to go. All right, the training is complete. Our machine has crunched the numbers on all 1,300 of those past customers. It's time for the final verdict.
Let's see what it discovered. What did our machine learn is the real driver of health insurance costs? And here we go. The model's verdict is in. It's basically boiled everything down into a simple recipe. For every year older you get, it tacks on about $256. For every point your BMI goes up, add another $339. But just look at that top line. The single fact of being a smoker, that alone adds an average of over $23,000 to the bill. Wow.
Let's just pause on that for a second. $23,600. Just by drawing a simple line through the data, our model has put an exact price tag on the impact of smoking. That is the answer to our mystery. It isn't just one factor among many, it's the single biggest piece of the puzzle, and it's not even close.
But the real question is, does it actually work? I mean, can it predict real costs? Let's put it to the test. Here are a few random customers from our case file. You can see what our model predicted their cost would be, right next to what they actually paid. Now, it's not perfect, right? No model ever is. But it's pretty darn close. It's definitely in the right ballpark. It's making some pretty smart, educated guesses based on those patterns it found.
So when you boil it all down, what's the big takeaway here? We started with this messy pile of data, we followed the clues like detectives, and we used a machine learning model that's actually pretty simple. And just by doing that, our little model was able to cut through all that noise and find the one thing, the single factor that drives costs more than anything else.
And that really leaves us with one last kind of mind-blowing question, doesn't it? If a really basic model, just fitting a line to data, can uncover a secret this big, a $23,000 secret, hiding in a simple spreadsheet, just imagine what else is hiding out there. What other huge insights and crazy mysteries are just waiting to be discovered in all the data that's being created around us every second of every day? Makes you wonder, what are we going to